Hello and welcome to another tutorial. We are at the end of reviewing all the Java language basics. We went through the entire list, and it was a very comprehensive study of starting with knowing what the variables are, what are the primitive types, and what are the restrictions on naming variables. And then we looked at the arrays. We said that arrays are either of holding primitives or object references. Using the var type identifier, which is not a keyword, and only the use case is only for local variables. And then operators, we had a comprehensive study of the operators, expressions and statements, and code blocks. We said that a pair of curly brackets in Java in your source code determines a code block. Any local variable in that block is confined to that block itself. We had a very thorough look at control flow statements, conditionals or switches or loops for running a block of code repeatedly until some condition is met, like for loops, while loops, do while loops, etc. And then we looked at the traditional switch statements, and then finally we look at the newer version, which is a switch expression, which we can actually return some values. So let's head back to the list of tutorials, and now we're going to really get to the meat of the Java, which is object-oriented programming. So let's look at let's start with the definition of objects, classes, interfaces, packages, and inheritances. And obviously, so far in all the examples and demos that I've been showing you, I've been creating some classes. But these classes, the reason we create classes because the entry point to your program is always main, which is a static method, and that has to be inside the scope of a class, right? Everything in Java it should be inside a class, inside the scope of a class. And the scope of the class means the pair of curly braces that we open and close, which define basically in the source code. It shows where basically the code of the class starts and ends. So far we've seen that a source code, a .java file, which is also called a source code, can in fact contain more than one class definition. You can have multiple definitions. We saw that the restriction is that only one of the classes that are defined in a Java source file can be public. Other classes cannot have any modifiers. The only modifiers that the class definition accepts is public or no modifier. Like you either write public, you don't write anything. And the class that is public, the name of the class has to match the name of the Java source code. But when the compiler compiles all the classes in the Java source code, each one gets a separate class file. And that's one of the things about Java. Whenever the compiler compiles your source code, every class definition gets a separate source file. And the reason this happens is that sometimes in your program, when you run them, in the entire program, you might never use a particular class. And JVM only loads the classes in the memory on a need to use basis, which means if you never use a particular class in your program, JVM never loads it. So you kind of save on the memory and the footprint that the JVM needs, right? Because when the JVM loads a class into the memory, it means it creates a footprint for that class in the memory, and also has to keep track of the meta information of the class, which is saved in a reserved area in the Java heap, right? And we will look at these in more details in the future lectures. But what I'm trying to say at the moment is that a class is where your program starts, right? Because the entry point to your program has to be inside a class, just because there is no scope out of a class, right? There is no global scope in Java in your source code, right? Obviously, other programming languages like Python or C or C++, Python or C, C++, they do allow global scope. In C++, we call it namespace, global scope or global namespace. Just to give you a little bit more thing about C++, if you have a variable with the same name in a global scope, let's say I define $x equals 5, but then I also have a namespace. Namespace in C++ is like a package or something, right? And then I define that $x is 10. And then obviously I close that namespace. This is a very valid code. Let's give it a namespace something like n1. But then if you, because the C or C++ allows a global scope or global namespace, the question is, how do I, in my code, how do I differentiate between accessing this X inside a namespace or this variable inside a global scope, which is not. So in C++, the solution that they came up with is that you use the double colon, which is called the scope resolution operator, which means this tells the compiler where to look for a particular symbol, a variable, a symbol, right? So in the global namespace or the global scope, it doesn't have a name. So the key here is that the global scope or global namespace in C, C++, Python, it doesn't have a name. So you just say colon X, and because it doesn't have a name, it means it's a global scope. Whereas in the N1, you say N1, the name of namespace or the name of a scope, and then X, right? So this means a global variable, this means a scope variable. Now admittedly, this makes the code a little bit complex. That's why Java decided, no, there is no global namespace, there is no global scope. Everything has to be inside a class, right? So then if you want to, for example, run your main method in Java, you just say you use the it's a static method, so you use the name of the class dot main, right? And then you pass some array of strings if you want, or you don't pass anything, right? So you pass null, for example, or something. So basically what it means is that first of all, instead of a scope resolution operator in Java, it's simpler. Everything is dot, because everything is inside a class, and if you want to access some particular attribute of a class, like a field, a static method, instance method, you use dot operator. And we've seen that if you don't know, they actually added the scope resolution operator from Java 8 when they started working with lambda expressions and bringing or introducing a concise notation for the scope resolution operator. So in Java, we use the scope resolution operator for method references. And again, this is something that we will look at in the future lectures when we look at lambda expressions. So a method reference is basically you're telling that the compiler, hey, look up for this method in particular class. So you can say, for example, colon main. This means it's a static method inside this, and go and this kind of method reference again binds to a functional interface, right? And or introduces a concise notation for lambda expressions. So object, classes, interfaces, packages, and inheritance. If you've never used an object-oriented programming language before, now the opposite of object-oriented programming is procedural programming. Everything is a function, and you just pass the parameters to function, and the function returns one value or multiple values back, right? Now usually in the statically typed languages, the function has to have a return type, and when you have an int value, for example, as a return type, you cannot return multiple values, like 2 ints. That's not allowed. Now in programming languages like Python, they went around this by introducing the built-in type of tuple. Tuple is just a collection of values. So in Python, for example, you can define a method, func1, or define a function. It takes parameters, but then what you get at the end, you can say return, for example, x1, x2, etc. And what this does, this is just a syntactic sugar. In reality, what the Python runtime does, it returns a tuple of x1, x2. And the reason you don't worry about this is because tuple is a built-in type. Now in Java, there is no such thing as a built-in tuple. So the idea in Java is that, okay, you cannot return 2 values directly like this syntax, but you can always wrap them in a class, right? In C, C++, we use the plain old data types, POD, for example, and these are just struct, right? At the moment, the only use case for struct in C++ is to group together a couple of values. And then because struct in C++ or a class definition in Java allows you to group data, and it also allows it defines a new type, and that new type can be returned from method, right? So in Python has a more concise notation of returning multiple values. In C, C++, or Java, this obviously C doesn't allow classes, right? So only in C++ or Java, you can instead of define a new class that holds the group of values that you want to return. Now, obviously, in Java, in the most recent versions you have access to record, which is a nice built-in type. And that pretty much is equivalent to the tuple concept in Python, right? So this is equivalent to tuple concept in Python. And what this does is that tuples in Python, if you're not familiar with, they're immutable. When you create them, you cannot change them. The only thing that you can do, you can access the values, right? Same with records. Records are immutable. Once you create them, they define a new type, so you can return them from a method, but they're immutable. So when you return, the only thing that you can do with the record is to read those values, right? And again, we will look at the records in the future lecture. Alright, you will need to learn a few basic concepts before you can begin writing any code. And these concepts are directly associated with the object-oriented programming language, right? And then Java basically is built on top of the idea of the object-oriented programming. This section will introduce you to objects, classes, inheritance, interfaces, and packages. Now, we've looked at this before. A class is a footprint on how to group a set of data, which are class fields, or class member variables, and actions that happen on that group of data, which are class methods. And methods can be static or non-static. Same with the fields or the data that the class holds. It can be a static field or a non-static field. And then object is an instant and concrete built of a class of that footprint that actually holds data. Remember, a class itself doesn't hold any data, but it just defines the fields or variables. But when you create object, you actually assign values to those data. And non-static fields or non-static member variables, they define the state of the object, right? Inheritance means now you have classes. Classes can inherit from each other. The main benefit of inheritance is code reusability. If you define a class that does some stuff, you can inherit from it, and you automatically have access to all those public methods and fields in the original superclass or the parent class. Interfaces are basically abstract contracts that you define for your program, and any class that inherits from that interface has to abide by that contract, which means interfaces provide abstract definitions, and the classes have to override those definitions and provide their own implementation. And again, the reason that they call it in Java, basically they beautifully call it interface, because these are really like an interface, which means a user only interfaces with this interface basically, and what it means is that the user immediately knows what methods are available. And then if a class is implementing that interface, it's guaranteed to provide that contract. And packages are like namespaces in C++, right? There's the same way to provide or group a collection of classes together. Same with namespace. And the definition is that in C++ namespace, you can have classes or just standalone functions in C++ inside a namespace. And again, in Java, only classes are allowed to be as part of a namespace, which is a package, right? So the equivalent of a namespace in Java is a package. And again, the whole reason is that you might have classes with the same name in different packages. That's allowed because the runtime, the JVM knows that if you say, for example, in my case, if I have a class, let's call it class 1. That's the name of the source file, right? If I say loops.class1, the compiler, the JVM knows where to find it. If I say operators.class1, the compiler knows that it has to look for the class 1 class file inside the operators folder or operator package. And when you compile your Java and eventually package it as a jar file, right? That's the eventual that's the final goal of your Java project, right? You want to compile it and then package it so that you can distribute your binary code. Normally we don't, in the compiled languages like C, C++, Java, we don't distribute the source code. Obviously in Python we have to distribute the source code because there's really no binary definition. I mean, Python also compiles to the bytecode, but you don't distribute the bytecode. You just distribute the source code. But in Java, you can package the binary as a source file because JVM works with the binary, right? JVM doesn't understand .java files. So each discussion focuses on how these concepts relate to the real world while simultaneously providing an introduction to the syntax of the Java programming language. Now, so the topics here are a very rudimentary introduction, and what is an object, what is a class, what is inheritance, what is an interface, what is a package, right? An object is a software bundle of related state and behavior, which means once you have a footprint and you create a concrete instance of that footprint, you assign values or data to that footprint, right? The field that inside your class definition, now they actually hold the data. That means you give that object an instance of class, a state, and behavior is obviously the methods that work with those data. This section explains how a state and behavior are represented within an object, introduces the concept of data encapsulation, which means you provide access modifiers to the fields and methods. And you've seen that so far. For example, if I open a class, we have double, it doesn't provide any access modifier, which means it gets the default access modifier, which means a class level or a package level access. Other classes in the same package can directly access this field. But constructor is when you call it, you want to create an instance, an object of this footprint of this class, and they could be public, protected, private. Methods can be public, protected or private. These are all access modifiers, which means to other classes in the project, which methods they can directly access, or which ones you don't want them to access, right? Introduces the concept of data encapsulation and explains the benefits of designing your software in this manner. Objects share two characteristics. They will have a state and behavior. A state means the data, the fields that object holds, right? The data, the values of those fields. And behavior, the methods that act on those data, right? The state. Behavior acts as a state. Dogs have a state: name, color, breed, hungry, and behavior: barking, fetching, wagging tail. Bicycles also have a state: current gear, current pedal, cadence, current speed, and behavior: changing the gear. So note that what happens when you say behavior, it means some action. So a state means some data, something that is doesn't imply changing or some sort of action, just is some data, right? A state, like the current gear, this is a data, it doesn't imply any action. But changing the gear is an action, which means behavior, and that changes the state of the object, right? So if you have an action like changing the gear, the current gear changes, right? So we change the state. Identifying the state and behavior for real-world objects is a great way to begin thinking in terms of object-oriented programming. Take a minute right now to observe the real-world objects that are in your immediate area. For each object that you see, ask yourself two questions. What possible states can this object be in? And what possible behavior can this object perform? Make sure to write down your observation. As you do, you'll notice that real-world objects vary in complexity, right? And the typical approach is to use composition, which is one of the design patterns in Java, in which you can create a very complex object from a smaller, simpler objects, which means the complex object has fields. The fields are already other objects that encapsulate some of the behaviors and actions. And we will have many of these examples over this course. But what I'm saying is that composition is a very important topic in object-oriented design. Make sure to write down your observations. As you do, you'll notice that real-world objects vary in complexity. Your desktop lamp may have only two possible states, on and off, and two possible behaviors, turn on and turn off. But your desktop radio might have additional states: on, off, current volume, current station, and behavior: turn on, turn off, increase volume, decrease volume, seek, for example, search for a channel, scan, and tune. You may also notice that some objects in turn will also contain other objects, and this is the composition that I mentioned. These real-world observations are a starting point to understand the world of object-oriented programming. So methods, fields, right? A software object is basic. Methods are actions, and the fields are a state or data. And methods or behaviors or actions, they act on the fields or a state of the object. And if a method actually changes the state of the object, it's also called a mutator, which means it's mutating the state of the object. For example, if you're already familiar with setter methods in Java, that assigns a value to a given field. So you set the value of that field. It's called a setter, or sometimes a mutator, because you are mutating the state of the object. So methods that change the behavior of the object, or methods that change the state of the objects, are sometimes also called mutators. Now in Java, you cannot really tell if a method is allowed to change the behavior of the object or not. But in C++, for example, there is a keyword called const. So if you say a method of object is const, which means it's guaranteed that not change the behavior or the state of the object. So if a method that is const in C++, if you try to mutate the state of the object inside that method, the C++ compiler gives you a compilation error and says that you are not allowed to change the state of that object in this method. But in Java, there is no such thing. So sometimes you might see some weird behaviors that you don't expect. So you have to be very careful, right, when you try to externally mutate the state of an object. Software objects consist of a state and related behavior. An object stores its state in fields. And we've looked at this concept before. Fields are just variables that hold the data that define the state of the object. Fields are also called variables in some programming languages. In other programming languages like C, C++, we saw that there is a global scope, whereas in Java, there is no global scope. The only scope is the scope of a class. In C++, fields of a class are called member variables. Member means they belong to a class, they belong to an object. And when we say variables in C++, it usually means global variables. Variables that are in the global scope do not belong to a specific class. So sometimes I would say fields, sometimes I say member variables. You can always use these in place of each other. And exposes its behavior through methods, functions in some programming languages. And again, in Java, we say methods. In C++, some people say member functions. And again, a function that belongs to a class, it's a member of a class. So methods or member functions. Methods operate on an object's internal state and serve as the primary mechanism for object-to-object communication. And again, the method can change the state of the object. In that case, it's categorized as a mutator method. Or a method doesn't change the state of the object. For example, it just returns a value to whomever called that method, right? In that case, that method is not a mutator. Hiding internal state and requiring all interaction to be performed through an object's method is known as data encapsulation. And this is one of the 4 pillars of object-oriented programming, data encapsulation. The idea is that the end user, or to the external world, it doesn't have to be concerned with the internals of the class or the objects. They just interact with the object with a known contract, which is defined by the methods, right? The actions that the outside world can ask the object to do, right? Methods are the actions that the object can do. A fundamental principle of object-oriented programming is data encapsulation. Consider a bicycle, for example. It has some data, right? 5th gear, 25 kilometers per hour is the speed. This is the RPM, basically 90 RPM. And there are actions, for example, brake, change cadence, change gears. These are the actions that a bicycle object can do, right? And these are the methods, basically. By attributing a state, current speed, current pedal cadence, and current gear, and providing methods for changing that state, the object remains in control of how the outside world is allowed to use it, right? And again, the internals, we encapsulate the data or the state and let the outside world interact with this data through the methods that, or basically the contract that the object provides through these actions, right? The outside world doesn't, in a good object-oriented programming code, for example, in a well-written code, the outside world doesn't directly access this data. Instead, it interacts with them through the methods, through the contracts that the object provides. And later we will see that this concept will generalize into the concept of interfaces, some abstract contracts that an object is guaranteed to provide, right? So interfaces are a generalization of this concept that the interaction with the object is through some contracts, which are defined as methods inside that object. and providing methods for changing that state. The object remains in control of how the outside world is allowed to use it. For example, if the bicycle only has 6 gears, a method to change gears could reject any value that is less than 1 or greater than 6. And again, this is another good reason why we interact with the object, with the state of the object through the methods, because inside the method, instead of directly accessing the gear and trying to assign a new value, you call the change gears and pass your value. And inside the method, we can actually do some checks, right? And validate that the input is actually correct. If it's not, usually in Java, we throw exceptions, right? Saying that, hey, this is not allowed. And then if you throw a, for example, checked exception, then you have to manage it yourself. If it's a runtime exception, then it's just your program just crashes, right? So inside the methods, you can have some checks, and that's why having getters and setters are the common practice in Java programming language. And most IDEs just automatically generate those for you. So let me just let me create a new package here, .oop, and here let's call this let's create a class bicycle. All right, and let's have a main method here. For example, we didn't need to have a main method. What I want you to show is that, let's say int gear, right? This is a data, and then int speed, right? So this is the state of the object, and we already know that, for example, a bicycle can only have a limited set of gears, right? For example, gear 1, 2, 3, 4, 5, or maybe -1 for reverse. I mean, a bicycle, let's change this to car. So refactor, rename car. And the reason I'm using a refactor rename, because I want to Eclipse to automatically rename the source code. Remember, the public class, the only public class in a Java file, has to have the same name as the source code, right? And then what we want, we don't want the outside world, when they create an instance of the object, we don't want them to directly access this. At the moment, they can't. The only classes or the only people that are allowed to directly access these fields are the classes in the same package in this OOP, right? So these are the fields or member variables that define the state of the object. An object means once we create an instance, remember, the class definition is a footprint, so we don't assign data to it. We know that when JVM initializes this class, when it loads this print, because whenever you want to create an instance of a class, the JVM has to first load the definition of the class or the footprint into the memory, into its Java heap, right? And the definition is just then the JVM knows what fields this class has and what type those fields are, right? And what methods are there. And then when you use a constructor to create an instance of the class, then you pass or assign values to this. But the thing here is that JVM doesn't like, or basically in general, Java language doesn't like ambiguity or undefined behavior. That's why even when the JVM loads this footprint, it assigns default values to these variables. And we've already seen that the int gets a default value of 0, right? So if you create an instance of this class and not assign any values, these values are already 0 by default, right? In C++, these have undefined variables, some garbage variables, and you have to manually initialize them. Now you can initialize them by assigning, for example, default values. So this means whenever this footprint is loaded, the gear automatically is at 2, right? Let's say you have a car or some object. It makes sense that whenever somebody tries to create that, by default it's at some gear, for example, right? If it makes sense, assign default values. So you can assign default values, right? But then it's not necessary, and it's not necessary. You don't have to do it, but at the time of creating an instance or an object of that class, you can set the values to what you want. But then instead of people directly accessing these fields, we want to do data encapsulation. Data encapsulation, which means we enforce that these fields are completely private. Private means no one is allowed to access these. Even classes in the same package, they're not allowed. And again, if somebody wants to read the value of the gear of speed, they have to use a getter or call a getter. So we right click source, generate getters and setters, and we select our fields, right? Get gear, set gear, and then a speed, get a speed, set a speed, right? And then we generate these, and now we have these getters and setters. And getters are sometimes called accessors, which means you just access the value, but you access the value, but a value that is private, which means basically you don't directly access that, you just use a get. And this is nice because your IDE probably has code completion, and I know that if I want to read a read a value, I just type dot get, and it tells me which attributes this has. So if I, in order to show you, let's say main, and then I create car1 is new car. Now we haven't talked about constructing objects, but you have to create a new, use the new operator. Right now I have calling a constructor to give me a car with the default values, right? Now here I can say car gear 1, I can access this, and the reason because I'm already inside the scope of this class, so I can access the private methods. So I can say car1.gear, and this is allowed because although it's a private value method, it's already, I'm already inside the class itself, so I can access. But instead of doing that, I want to see what attributes this has, right? And again, data encapsulation means you are going to make everything private. Then the question is, how do we know what values, what attributes this car has? And now the thing here is that later on, when we look at how to create Java documentation for your code, usually you don't document private fields because these are the internals of the class. So Java doc usually deals with the public interface, the public methods or the public variables that others are allowed. Instead, what you can do, you can say car.get, and it tells me what attributes it has. Now it inherits the get class, but it also tells me that get gear, get a speed, which means that this car, whoever designed this class gave me an interface to, or a public interface to read two attributes of this car. One is gear and a speed. That's why the contract of getters is very nice, because you just immediately say .get, and the autocomplete immediately tells you which attributes you are allowed to read. Same with set, car.set, it tells immediately what attributes you can override or change, right? And again, the nice thing about setter is that if I say car1.set gear, let's say gear 4, remember the default is 0, right? And then get gear, I set the value and then read it again. This going to read the value of 4, which means I have successfully changed it. But the beauty of setters, which are also called mutators, is that now you can do additional checks. For example, if somebody was allowed to say car.gear equals 7, there is no way that you can do additional checks. But here we can say if, for example, is gear is greater than 6, we can throw an exception or refuse, we can return, right? Remember, the setters usually return void, they don't return anything. And we can return something, for example, sysair gear has to be less than 7. So we refuse to change the state. Set gear 4, right? And then right now we're setting to 4 now, and it works. But what about we set it to, for example, 10? As you can see, we are printing an error. I'm using the error stream, which to the console it prints red in Eclipse, which is nice, right? Saying that gear has to be less than 7, and we refused to change the state of the object. That's the key here. We just immediately returned, and we have already saw that what the meaning of return is. It just jumps out of the method, and it doesn't execute the rest of the code. So here we refuse to change the state of the object if the value is not valid, right? So that's the beauty of setters instead of directly accessing them. Note that if this gear was public and somebody could set it to 10, there is no way there is no way to refuse or prevent this, right? Because this is direct access, and that's bad. So this is very bad practice. And that's the whole concept of data encapsulation. You wanna let's say the car has lots of 10 fields, but you want the user to only be concerned with the gear and speed. Then you make all of them private. You only define a getter for the gear and a getter for the speed. Then when the user types car1.get, it realizes that there are only 2 values that you can read or ask the car what the value of those fields are. The rest the user doesn't have to be concerned with, right? So one of the ideas about designing good API or classes is to really from the beginning think about which parts of your class you're going to expose to the user, allow the user to read some values or set the values, which parts are private, the user shouldn't be able to access or touch them. Later on, when we look at Java reflection, we see that a lot of these stuff can be circumvented using for example, the Java reflection, which we use. It gives us access to the meta information of the classes at runtime, right? All right, so bundling code into individual software objects provides a number of benefits: modularity, information hiding, which is data encapsulation, code reuse. Later we look at inheritance, pluggability and debugging easy, which means we break the big problem into smaller classes. And because the classes are small, we can test them separately. Once a class is fully tested and it works well, then we put them together and create a bigger object or bigger class. And this is also called separation of concerns, which means you have to really design a class that only is concerned with a very particular thing. You shouldn't have some people call it God object, an object that does everything. That's bad. Instead, you should always favor composition. Define smaller objects and then use them as fields of a bigger object. For example, if I say a string name or model, and then let's call it Ford, for example. Remember, a string is an object. It's not a primitive. So this field is actually an object. Its field is an object, which is also a field on another object, and this is called composition. Now we can even have a circular composition, which is very nice thing that Java allows, and that's a class can hold a field of its own type, car, other car, or basically I don't know, other model. So this is called basically a class can have a field of its own type. This is kind of like a circular composition. Now this, if you're familiar with C++ and manual memory management, you know that this kind of circular references is very tricky when it comes to memory management, but Java's garbage collection is very smart. So you as a programmer, you don't need to be concerned about anything in terms of memory management. You just write your beautiful code and it will work very well. So I hope you enjoyed this lecture. Please stay tuned and I'll see you in the next one.